Hello and welcome to another episode of Truth Explained. I'm Hugo Pellegrino, and since this is the first video of the year 2022, today I'll be talking about artificial intelligence. As always, thank you very much for watching today's videos. And as always, we do have English, Spanish, French, and Portuguese subtitles. Today I want to talk about both sides of artificial intelligence, the good side and the bad side. Since we're beginning a new year, let's talk about them.
Artificial intelligence, the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. The term is frequently applied to the project of developing systems endowed with the intellectual processes characteristic of humans, such as the ability to reason, discover meaning, generalize, or learn from past experience. Since the development of the digital computer in the 1940s, it has been demonstrated that computers can be programmed to carry out very complex tasks, as, for example, discovering proofs for mathematical theorems or playing chess, with great proficiency. Still, despite continuing advances in computer processing speed and memory capacity, there are as yet no programs that can match human flexibility over wider domains or in tasks requiring much everyday knowledge. On the other hand, some programs have attained the performance levels of human experts and professionals in performing certain specific tasks, so that artificial intelligence in this limited sense is found in applications as diverse as medical diagnosis, computer search engines, and voice or handwriting recognition. What is intelligence? All but the simplest human behavior is ascribed to intelligence, while even the most complicated insect behavior is never taken as an indication of intelligence. What is the difference? Consider the behavior of the digger wasp, Sphex ichneumonius. When the female wasp returns to her burrow with food, she first deposits it on the threshold, checks for intruders inside her burrow, and only then, if the coast is clear, carries her food inside. The real nature of the wasp's instinctual behavior is revealed if the food is moved a few inches away from the entrance to her burrow while she is inside. On emerging, she will repeat the whole procedure as often as the food is displaced. Intelligence, conspicuously absent in the case of Sphex, must include the ability to adapt to new circumstances. Psychologists generally do not characterize human intelligence by just one trait, but by the combination of many diverse abilities. Research in AI has focused chiefly on the following components of intelligence: learning, reasoning, problem solving, perception, and using language. Learning. There are a number of different forms of learning as applied to artificial intelligence. The simplest is learning by trial and error. For example, a simple computer program for solving mate-in-one chess problems might try moves at random until mate is found. The program might then store the solution with the position so that the next time the computer encountered the same position it would recall the solution. This simple memorizing of individual items and procedures, known as rote learning, is relatively easy to implement on a computer. More challenging is the problem of implementing what is called generalization. Generalization involves applying past experience to analogous new situations. For example, a program that learns the past tense of regular English verbs by rote will not be able to produce the past tense of a word such as jump unless it previously had been presented with jumped. Whereas a program that is able to generalize can learn the add rule and so form the past tense of jump based on experience with similar verbs. Reasoning. To reason is to draw inferences appropriate to the situation. Inferences are classified as either deductive or inductive. An example of the former is, Fred must be in either the museum or the cafe. He is not in the cafe. Therefore he is in the museum, and of the latter, previous accidents of this sort were caused by instrument failure. Therefore this accident was caused by instrument failure. The most significant difference between these forms of reasoning is that in the deductive case the truth of the premises guarantees the truth of the conclusion, whereas in the inductive case the truth of the premise lends support to the conclusion without giving absolute assurance. Inductive reasoning is common in science, where data are collected and tentative models are developed to describe and predict future behavior, until the appearance of anomalous data forces the model to be revised. Deductive reasoning is common in mathematics and logic, where elaborate structures of irrefutable theorems are built up from a small set of basic axioms and rules. There has been considerable success in programming computers to draw inferences, especially deductive inferences. However, true reasoning involves more than just drawing inferences. It involves drawing inferences relevant to the solution of the particular task or situation. This is one of the hardest problems confronting AI. Problem solving, particularly in artificial intelligence, may be characterized as a systematic search through a range of possible actions in order to reach some predefined goal or solution. Problem-solving methods divide into special purpose and general purpose. A special purpose method is tailor-made for a particular problem and often exploits very specific features of the situation in which the problem is embedded. In contrast, a general-purpose method is applicable to a wide variety of problems. One general-purpose technique used in AI is means-end analysis, a step-by-step, or incremental, reduction of the difference between the current state and the final goal. The program selects actions from a list of means. In the case of a simple robot, this might consist of pick up, put down, move forward, move back, move left, and move right, until the goal is reached. Many diverse problems have been solved by artificial intelligence programs. Some examples are finding the winning move in a board game, devising mathematical proofs, and manipulating virtual objects in the computer-generated world.
If you're getting a little bit tired, you can always pause the video, get a little bit of water, some popcorn perhaps, and go to my Patreon channel. The link is down below to support me.
According to the UCLA, experts consider how the growing use of AI will impact civil liberties. Artificial intelligence is playing a growing role in our lives, in private and public spheres, in ways large and small. Machine learning tools help determine the ads you see on Facebook and routes you take to get to work. They might also be making decisions about your healthcare and immigration status. Government agencies at the local and federal level are exploring, and in many cases already using, automated tools to allocate resources and monitor people. This raises significant civil rights and civil liberties concerns. In some cities, police are using artificial intelligence to predict where crimes might occur and to deploy officers and surveillance technologies accordingly. The former Trump administration wanted to collaborate with Silicon Valley to build a system to mine the social media accounts of foreigners. In one Pennsylvania county, an algorithm determines which children are at risk of abuse. As these examples make clear, disfavored communities and populations already subjected to disproportionate government scrutiny will bear the brunt of these new technologies. Worse, such algorithms tend to be shrouded in secrecy, closed off to external auditors who might be able to test them for bias and make needed corrections. Because of that secrecy, often imposed by private companies that refuse to reveal their source code, people can't effectively contest the decisions made by these tools. The data and algorithms used to make fateful decisions about people's lives are simply out of public reach. In many contexts, the government's use of automated tools to increase efficiency and assist in decision-making is appropriate. However, safeguards are necessary to give human beings a role in their creation, oversight, and deployment. Without democratic participation, we have no way to ensure that artificial intelligence isn't exacerbating inequality and obstructing human agency, possibly without our ever knowing. If we have learned anything in the last decade about our criminal justice system, it is how astonishingly dysfunctional it is. Extensive investigations have revealed persistent racial disparities at every stage, a different kind of justice for the haves and the have-nots, and a system that neither rehabilitates individuals nor ensures public safety. In short, the system is in crisis. Rather than scrapping everything and starting anew, many criminal justice stakeholders have turned to technology to repair the breach through risk assessment tools. Also labeled artificial intelligence, automated decision-making, or predictive analytics, these tools have been touted as carrying with them the potential to save a broken system, and they now play a role at nearly every critical stage of the criminal justice process. If we're not careful, however, these tools may exacerbate the same problems they are ostensibly meant to help solve. It begins on the front lines of the criminal justice system with policing. Law enforcement has embraced predictive analytics, which can pinpoint areas allegedly prone to criminal activity by examining historical patterns, and then deploy officers to those areas. In Chicago, for example, the predictive tools analyze complex social networks through publicly accessible data in an attempt to forecast likely perpetrators and victims of violent crime. Once an individual is arrested, they are likely to be subjected to a pre-trial risk assessment tool. Such tools are used to inform the thinking of a judge who must decide whether to incarcerate that person pending trial or release them. Pre-trial risk assessments attempt to predict which of the accused will fail to appear in court or will be rearrested. Some states have used these pre-trial tools at the sentencing and parole stage, in an attempt to predict the likelihood that someone will commit a new offense if released from prison. While all of this technology may seem to hold great promise, it also can come with staggering costs. The potential for bias to creep into the deployment of the tools is enormous. Simply put, the devil is in the data. All risk assessment tools generally rely on historical, actuarial data. Often, that data relates to the behavior of a class of people, like individuals with criminal records. Sometimes it relates to the characteristics of a neighborhood. That information is run through an algorithm, a set of instructions that tell a computer model what to do. In the case of risk assessment tools, the model produces a forecast of the probability that an individual will engage in some particular behavior. That order of operations can be problematic given the range of data that fuels the forecast. Data scientists often refer to this type of problem as garbage in, garbage out. In a historically biased criminal justice system, the garbage in can have grave consequences. Imagine, for a moment, a city where black people made up 67% of the population, but accounted for 85% of vehicle stops, 90% of citations issued, 95% of jaywalking charges, 94% of those charged with disobeying the order of an officer, and 93% of the arrests made by the city's officers. What about a city where black people comprised 54% of the population, but 85% of pedestrian stops and 79% of arrests by police, and were 2.5 times more likely to be stopped by the police than their white counterparts? Or a police department that singled out a city's black and Latino residents for 83% of all stops, but 88% of the stops resulted in no further action? These aren't imaginary cities or made-up numbers. They are drawn from Ferguson, Missouri, Newark, New Jersey, and New York City, respectively. It is now well known that the police forces in these cities engaged in racially biased policing on the false assumption that doing so was an effective means of fighting crime. In the case of Ferguson, fighting crime was only half the goal. Generating revenue for the municipality through law enforcement was the other. Now consider the potential harm done when police departments like these use their crime data to feed the algorithms and models used to predict behavior. If one only examined the data, the working assumption would be that white people rarely engage in criminal activity. Most algorithms would simply predict that these disparate numbers represent a real, consistent pattern of criminal behavior by individuals.
So what do you think artificial intelligence will be like? Will it only be used for good? Or a possibility of artificial intelligence being used for bad? I do want to know. So please let me know on the comments down below. As always, thank you very much for watching today's videos. If you have any doubts at all, you can always send me an email at hugo.loh@gmail.com. As always, thank you very much for watching today's video.